Okay, so this is the cylinder problem. So one of the problems we had on the assignment looked like this. And it had a cylinder, and it wants to know the surface area of a cylinder that has a cylinder cut out in the middle. So you have to realize that the surface area includes everything that the air can get to. So I'm going to wrap this up here like this. This is a rectangle like this, okay? So this outside sleeve is part of the surface area. Now this is the circumference of the bottom circle times how tall it is. So to get the area of this piece, you would have to do 2 pi r times h. So I'm going to write that down. That's the area of the outside of this big cylinder. So that's 2 pi capital R times h. That is this larger piece here. Now, if I take this and set it aside, also I look and I can see that the inside is hollow, and because it's hollow, you have to realize that air can get inside of there. So I have to figure out how big that inside sleeve would be. So I took another piece of paper like this, and I'm going to wrap it up like this. And if I put it inside, so you can see what I'm doing, hang on. So this piece here would have to match the inside part there. That is included in the surface area. So if I take that out and I open it up, that is 2 pi little r times h. That's the little cylinder rectangle inside. So that is 2 pi little r times h. And I would have to add those together because you have to have both of those calculated in the surface area. Now furthermore, if I look at the end, I see that there is a circle here on this side, and there's a circle here on this side, but we can't count those circles because there's a hole in it. So actually, we're not going to add these. We're going to add this for that one, and this for that one. So these two rings, or donuts, actually that's called an annulus, which we've done before, has to be included, and we have 2 of them, like that. So this formula for annulus was pi r squared minus little pi r squared, and we have to take that answer and we have to do times 2 because you have 2 of them. So this is our strategy. We're going to take the outside panel here for the outside of the cylinder, plus we have to do the smaller rectangle, which is the inside surface area of our cylinder right here, plus the 2 annulus or 2 donut shapes on the end. So according to the worksheet, let me find where the worksheet is, or the assignment. The big radius, okay, so they're saying the diameter all the way across is 8, so this is 4. And for the little one, the diameter is 4, so this is actually 2 for the radius. So this is 2 times pi, this is for the bigger one, has a radius of 4, and according to the picture, the height is 9. This was given on the assignment, plus 2 times pi times the little radius of 2 times the height of 9. So that takes care of those 2 shapes. Plus, now let's figure this out. This is going to be pi 4 squared minus pi 2 squared times 2. And the first thing I'm going to do is I'm going to do this all in terms of pi. So 4 times 9 is 36. 36 doubled is 72 pi. Plus 18 times 2 is 36 pi. So I took care of that and that. Now this is 16 pi minus 4 pi, which gives us 12 pi, but I have to double it, so plus 24 pi. So this is going to give me all of the surface area. So we're going to do 72 plus 36 plus 24. So this is 132 pi centimeters squared. And this is the exact answer of all of those pieces. Now I'm going to do times pi, and I'm going to round it to 414.69. Or I could say 0.7 centimeters squared, and that's an approximate answer. Let me move that up a little bit so you can see it. That's the approximate answer. So, one more time, to find the surface area of this, we have to find the outside piece, which was 72 pi. We have to find the inside piece, which was 36 pi. And then we have to find each of these, which was 12 pi, and another 12 pi, which gives us 24 pi, and add them all together. So that was the cylinder problem. Then we used the paper towel roll to discuss.